Okay, so here are our notes for the law of cosines. When you go back to the law of sines and what we talked about yesterday, you needed a matching pair. What I'm meaning by a matching pair is you had a side and you had its matching angle. So one of the situations, either side A and angle A, or side B and angle B, or side C and angle C. You had one matching set. What happens though when we don't have a matching set? Matching sets won't happen if it's side angle side. And as a reminder, what side angle side would look like, it would be a side, the angle included in between your two sides. That would be a side angle side. That's one example. Or potentially you could have this side, and it would be the angle where those two sides touch. That's another side angle side. And last but not least, you could have the bottom and the side over there, and that would be a side angle side. Okay, so those will give you situations where you don't have a matching set, and same thing with side, side, side. So here's our law of cosines. Law of cosines is what you would have to use if you do not have a matching set. Law of cosines goes like this. It is side A squared is equal to side B squared plus side C squared. So notice it kind of looks like Pythagorean theorem at this point, and all of your sides are used. But here's where it gets tricky. You're going to subtract the two sides that are on the same side as the equal sign, and those two sides are sides B and C. So all of that's multiplied together, and you are multiplying all of that by the cosine of angle A. And what I want you guys to notice is you started with side A and you're going to end with cosine of A. The two sides, what I'm talking about a moment ago, the two sides were sides B and C, and they were on the same side as the equal sign as you were working with. And let's do that one again because it's all the same pattern. So let's do this next one. Another version of law of cosines would be if you were saying B squared is equal to, well, we've got to find the other two sides. The other two sides are A and C. Minus those two sides were A and C, multiplied by the cosine. I started with side B, so I'm going to end with cosine of B. And last but not least, the third variation or third version of this is if I had C squared on the left. The other two sides in my triangle would be A squared and B squared. I'm subtracting 2, and the two sides on that same side of the equal sign are A and B. And I'm multiplying by the cosine of, I started with side C, so I'm going to end with angle C. So these are my three variations. The biggest thing that you probably want to pay attention to is the angle. If you are using or finding angle A, then you better use this version over here. If you are using or finding angle B, then you got to use that one. That's the only version that has angle B in it. And if you are solving for or using angle C, you have to use that bottom version. That's the only version that includes angle C. So let's look at my problem. If I labeled this as A, B, and C, I do not have a matching set, and I'm going to go ahead and I see that I have angle B, and here's side B. There's not anything matching. I have a side angle side. The 16 and the 28 intersect and form that 127-degree angle. So I'm going to use the B squared equals A squared plus C squared minus 2AC multiplied by the cosine of angle B. The reason I'm using this version is because I know what angle B is. Angle B is 127. So I'm going to fill in the blank. Side B is across from angle B, so that would be x squared equals side A is across from angle A, so this would be 28 squared. Side C is across from angle C, so this would be 16 squared minus 2 times 28 times 16 times the cosine of 127. Now, what I want you guys to notice is that all of this is multiplication. Order of operations has us taking care of multiplication first. So in my calculator, I'm going to go ahead and pull this up, and I'm going to do that multiplication. I have 2 times 28, 2 times 28 times 16 times the cosine of 127. That number comes out to be negative 539. And watch the math on this. We have 28 squared plus 16 squared minus, look at my calculator, I did not put in negative 2. I just did the 2. It was highlighted. So I actually have a minus negative 539.23. Okay, that comes from my calculation work. And the double negative turns it positive. So if you watch my calculator at this point, I'm just going to plug in these numbers. 28 squared plus 16 squared minus negative 539.226. Press enter. Now this gets me x squared is equal to that number, 1579.226. And I'm going to square root that answer. So my side length comes out to 39.7. They want it to the nearest tenth, which is 1 decimal place. Moving on to the next example, kind of paying attention with what I've got. I've got this angle and this side. That's what I had hoped to be a matching set. If it was a matching set, it would be a law of sines, but it's not. And I have this side and this side. So this is definitely a side angle side situation. So I'm going to say x squared equals 25 squared plus 12 squared minus 2 times 25 times 12 times the cosine of 36. Whatever side I started with is the corresponding angle that I end with. That's why I set that up that way. And because this entire side, if you guys look at it, I'm going to give you a short way to do this. None of that stuff on the right-hand side is a variable. So if you guys watch my calculator at this point, I truly can just plug that in exactly the way that I see it. Press enter, and this gives me what x squared is equal to. And I can take the square root of that answer, and I get out that x is equal to 16.84. Now in this next example, it didn't give me a picture, so that's going to be your first job, is we are going to draw triangle ABC. So we've got A, B, C. It told me C is 88, AC is 22, BC is 11.5. We are finding AB, which is that x right there. So setting up my law of cosines, because I have no matching sets, I would have x squared equals 11.5 squared plus 22 squared minus 2 times 11 times 22, 11.5, I'm sorry. Times the cosine of 88. Again, looking at this side, nothing is a variable over there. So you can watch my calculator. I can just type it in exactly the way that I see it. 11.5 squared plus 22 squared minus 2 times 11.5 times 22 times the cosine of 88. Make sure you're in degree mode in your calculator or all of your answers will be wrong. So I have x squared equals 598.59, and I'm taking the square root of that answer. My x is going to come out to be 24.46, which we could write as 24.5. Now in this next example, we're not finding a side anymore. This is a side, side, side. We're actually going to be solving for an angle. So if we go back to what we talked about yesterday, you're going to have to use inverse in your calculator. So if we look at this problem and go back up and look at my law of cosines, whatever angle that I am solving for is the side that I start with. So I'm solving for x. If you guys want to see, we can label it ABC. So I'm solving for angle C, which means I need to start with side C. I would have side C equals sides A squared plus B squared minus 2AB times the cosine of angle C. So this is what I'm plugging in. Side A is 13, side B is 11, and I'm multiplying those, and I have times cosine of angle C. Now I want to remind you guys, this is multiplication. All this stuff is lumped together. You cannot touch this. This is one big long grouping. You cannot subtract this. You have to follow order of operations. Order of operations says multiply first. So I have 2 times 11 times 13. This becomes minus 286 times the cosine of C. That can't be touched. I can do 13 squared plus 11 squared. Kind of combine this stuff to get 290 equals 100. 10 squared is 100. Following my algebra rules, to undo this problem, I would subtract 290 first, which would give me negative 190 equals negative 286 times the cosine of angle C. To get angle C by itself, I would divide, so watch my calculator. I am dividing by the negative 286. This gets me a decimal point of 0.6643 equals the cosine of C. And if you recall, to find an angle, you're going to use inverse. So watch my calculator. I'm doing inverse cosine, and I'm actually going to use my answer, my previous answer, so I don't have to do that big crazy decimal. That answer feature is that, and look in blue, it's above the negative, which is next to the enter. So second negative. Press enter, and angle C comes out to be 48.3 or 48.4 degrees. If we take a look at this next problem again, I'm solving for this angle, so it would be this side across from it that I start with. So I have 17 squared equals 18 squared plus 30 squared minus 2 times 18 times 30 times the cosine of x. I'm going to leave it as an x. If you want to label it, you can. Keep in mind, this is all lumped together. You can't touch that. It's all a big multiplication. So 2 times 18 times 30. I have negative 1080 cosine x. 18 squared plus 30 squared is 1224. And 17 squared is 289. My algebra would have me doing 289 minus 1224. This gets me negative 935 equals negative 1080 times the cosine of x. I'm going to divide that negative 935 by negative 1080. I get that little decimal point, which is good. 0.8657 equals cosine of x. And I'm doing inverse cosine of that answer. And I get x to come out as 30.03. I'm going to give you guys a moment here to try question number 6. I'll start you out with at least the picture. So right now, it is silent on the video on purpose. I'm giving you a moment to try this one on your own. I'll give you the answer in just a little bit. You may or may not be done, but that angle, if you are done, comes out at 137 degrees. As far as these applications go, you may skip for now question number 7. We will do bearing another day. And you may skip question number 8, but question number 9 we can go ahead and we can do together. So we've got our helicopter. Here's my little helicopter out front here. I'm not a very good drawer, but this comes up, and these are my little wing thingies. This comes up too. This is my little landing pads. Okay, not a great drawer, but you got the picture. And it spots 2 landing pads below. The straight line distance from the helicopter to the pads is 14 miles to landing pad A and 8 miles to landing pad B. If the landing pads are 20 miles apart, find the angle of depression. We haven't seen that in a while. Angle of depression from the helicopter to landing pad B. Well, that would mean that that's the angle right in there that we're looking for. But if you recall angle of elevation and angle of depression, that this line of sight and this ground are parallel. So those 2 angles are alternate interior angles, and they're going to be the same. So I'm going to go ahead and I'm going to do my law of cosines, and I'm going to find that angle B. So that would mean I would set this up with 14 squared equals 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of angle B. Well, 14 squared is 196. And 8 squared plus 20 squared is 464. Minus 2 times 8 times 20 gives me 320. 196 minus 464 is negative 268. Do some division by negative 320, and I get cosine of B is 0.8375, and the inverse cosine. Angle B is 33.12 degrees. This link is posted on Schoology as an update, as well as the answers to your homework. But as you guys go through, you should be able to do all of the law of cosines homework in there. And looking at it right now, there is one problem. I'm going to write it down here. You cannot do number 9, so no number 9. That's a bearing problem. And the rest of them, and number 11, don't do number 11 either. The rest of them you should be able to do. Okay? Number 9 and 11. All good. Have a great day, everybody.